This video we're going to talk about formula of iron. But before we move on, okay, we have a look of example 7.1 first, okay. Predict the ion formed by an atom. Okay, so we consider aluminium, which is Al. Write down the number of protons, electrons, and also neutrons in atom. So this is a full atomic symbol. This is the atomic number equals to proton number. This is mass number, which is equals to proton plus neutron. So for part A, we'll know that the proton should be 13. Neutron should be 27 minus 13, that means 14. And because this is an atom, so therefore proton number should equal to electron number, so this one should be 13. B, draw the electron diagram of an atom. This time we are drawing atom, so pay attention. Atoms, okay, we got 3 shells here. Okay, so you should have 2, 8, 3. Don't mix up this one with the ions, okay? We're talking about atoms, okay? And then briefly describe how the aluminium can get the stable octet structure. So you can see that actually right now it's not stable, okay? Because they have 3 electrons and the outermost shells only. So to make it stable, okay, you need to, by losing 3 electrons in the outermost shells. If you do like that way, outermost shell. If you do like that way, they will then become 2, 8. So you can have octet structure in outermost shells, they will become stable. Okay, so D, write the number of protons, electrons, and neutrons in aluminium ion. This time is ion, okay? So pay attention to that. Remember, when they form ion, actually they have no changes to the number of proton and neutron in the nucleus. So therefore, these two will keep the same. However, the number of electrons is lost in the process, losing 3 electrons in this case. So therefore, you have 13 minus 3, so you have 10 electrons this time. And what is the charge in it? Because we have 13 positive, 10 negative. So the charge for this one will then become 13 minus 10 will become 3 positive. Okay, the charge for aluminium. And you need to draw the electron diagram. This time we are drawing iron. So this is some things that you have to pay attention. In the exam, we may ask atom and iron, okay, at different times. Okay, so pay attention to the particles that you're dealing with. So for aluminium, okay, we are losing 1 electron shells and also 3 electrons. So therefore, at the end, okay, you will just have 2 shells only, and then we call it square bracket. This one is not drawing well. Okay, you have to be closing the mouth. So therefore, 2 here, 8 in the second shells, and then this is 3 positive, not positive 3. So basically, the questions in the exam will look like these. So before we talk about that, so now we talk about another thing. It's about the polyatomic ions. Ions is not that simple, okay? Remember, one form of ions, okay, the one that we learned in the front, okay, we call those simple ion. Simple ion, we just have 1 atoms only, okay? So for example, the one that we learned before, chloride ion, oxide ion, sodium ion, magnesium ion, we just have 1 atoms in it, okay? But if we have more than 1 atoms grouped together like these, more than 1 atoms grouped together, we call this polyatomic ions. Poly means many, okay? So basically, okay, we will say that, okay, when an atom gain or lose electrons, okay, they become ions. And simple ion referring to single atom, 1 atoms only. Polyatomic ion, we talk about a group of atoms, okay, more than 1. So now we know that to classify the ions, actually we can have 2 perspectives. The first one is based on the charge. If based on the charge, if it is positive, okay, that is the cats, okay, so that will be cat ion, okay. If they are negative, okay, okay, we call that anion, okay. So cation, anion. And then if we base on the number of atoms involved, okay, we will consider them as simple ion. We just have one atoms only. If we have more than one, oh, many atoms. So therefore, we call that polyatomic ion. So we just have one class practice, have a look. So the following table shows the number of proton, electrons, and neutron inside the particle, represented by letter W to Z. Particles are either atoms or ions. So that means they may be atoms or ions in it. Okay? So let's have a look. Identify which one is proton. Atoms, which one is ions first. Okay? So for atoms, we know that number of proton should be equal to the number of electrons. So right here we can see that proton and electrons are the same. Proton and electrons are the same. So Y and Z, these two should be atom. While W and X, they should be ion. And we can see W, we have 3 electrons more than the proton, so W should be 3 negative. While X, you have 2 protons more than electrons, so therefore X should be 2 positive. Okay, so after you write down these concepts, okay, we can then move on to the questions. A, which of the above particles are atoms of noble gas? Noble gas, it must have 8 electrons in the outermost shells. When you think about the electrons arrangement, you have to look at this. Okay, first of all, they are atoms. You have either Y or Z. Okay, so if you have talked about Z, it should be 2, 8. Y should be 2, 8, 2. So which one is noble gas? Obviously, Z is a noble gas. Okay, and we know that it is neon as well. Okay, which of the above particles are ions? Okay, so we have W and Z, X. So you can see that actually we do this we call this analysis before you read the question. Actually, you just help to manage the information that you have in hand. That is much more helpful, and they will be eventually useful at the end. So don't be hurried to read the questions, because after you get the questions, you not only have these information, you also have the information or request from here. You'll make yourself much more chaotic in your mind. Okay, C1, which of the 2 particles represent atom and ion of the same element? Elements, okay, it depends on the number of protons in it. So you can see that, okay, if we have same number of protons, they should be talking about the elements, same elements. So right here, okay, you can see that we have 12 protons for X and Y. So 2 particles represent the atom and ion of the same element. You should be talking about X and Y. While X is the ion, Y is the atom. Okay, so draw the electron diagram of the particle mentioned in C1. That means you have to draw X, and you can have to draw Y as well. But you can use the letter of the particle represent the atomic symbol. So you can use the letter of the particles. So the particle here, you should have 12. So you talk about magnesium. So for X, that is ion. Magnesium, ions. Magnesium, it should be 2H2. So the ion form should be 2,8. So magnesium, 2 circle. Okay, and then you go square bracket, 2, 2, 8. And then this is 2 positive. So this is the ion part. For the atom part, okay, magnesium atom, which is 2H2. So you have magnesium, 1 circle, 2 circle, and 3 circle. And no square bracket for this, because this is not an ion. So you draw like this way. Okay, 2H2. Okay, that is for C2. So now we come to the main focus of this chapter, name of ions. Basically, your task is to memorize the formula and memorize the name. Okay, if you know the name, if you know the formula, you know the charge. Okay, these are very, very, very important. Okay, so if you right now pause the video and go and memorize, that will be very good. Okay, but if you find it, oh, it is so many ions right there, okay? How can I memorize well, okay? Is there any rules? Okay, so in the following, I will give you some rules and help you to memorize a bit, okay? So indeed, actually, it is not very difficult, but this is very, very, very important, okay? If you don't know, if you don't want to memorize it, don't pick chemistry in Form 4 because you'll find it very hard to understand, okay? So this is the first steps, okay, that you make up your mind to study chemistry if you spend times in memorize these two tables, okay? So before we move on, so okay, I just want to suggest you, okay, try to memorize the whole things, okay, by categorize them, okay, into 2 pages. Okay, the one on the left hand side, okay, upper part will be positive, middle part will be 2 positive, lower parts will be 3 positive. So try to memorize in this sequence. So when you think of like iron 2 ions, okay, iron 2 ion happen in the middle, so you remember roughly it will be 2 positive. If you remember like chloride ion, which is on the right hand side and upper part of a chloride ion, then that will be 1 negative. So use their position, okay, on this page to help you to memorize the charge as well. Okay, that will be quite helpful as well. Okay, so let's have a look at the rules. So rule number 1, okay, most of the simple non-metal ion, okay, non-metal ion and polyatomic ion, they are anion, okay. Non-metal ion, say for example OS, N, Cl, Br, F, okay, all these non-metal, they are anion, 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 and anion, okay. So if you have polyatomic ion like this, or for example like this, okay, they are anion. So when you make a wild guess for this, okay, you should know that they should be negative, okay. But of course we do have exceptions, okay. We talk about the anion first, okay. You look at this, all the highlighted yellow one, they are simple ion, okay, simple ion on the right hand side, okay, all of them, they are negative, okay. And then the polyatomic ion, oh, you can see all the polyatomic ion, more than 1 atom, they are also on the right, okay. So when you make a wild guess, okay, it won't be positive in general, okay. But of course we do have exceptions, okay. The exception will be the hydrogen ion, that is a non-metal, but they can be H plus. But hydrogen is difficult, is different, okay. You have H plus and you also have H minus, so it depends on which one you're talking about that, okay. So hydrogen ion, okay, that is positive. Ammonium ion, I can pretty assure you that you must see this one in exam, okay. So this ammonium ion is extremely important, okay. Ammonium ion, NH4 plus. The spelling of it is AMMONIUM, okay. That is different from ammonia, okay. So ammonium ion, it is talking about NH4. All of them are non-metal ions, okay, but the charge for this is positive, okay. This is on the upper left corner, okay. Rule 2, okay, this one is very important, okay. Simple ion of main group elements, okay, main group elements. That means these 2 areas. This one, group 1, 2, 3, okay, and then 5, 6, 7, okay. So all these, okay, they have their charge, okay, related to their group number. So basically, group 1, you should have the outermost shells, say for example 281, 21, okay, 2881. So when they form ion, they must lose 1 electron in the outermost shells. So for group 1, it must be 1 positive. Of course, when you write, it should write positive only. When you have group 2, okay, that should be 22, 282, 2882. So for this, okay, they must lose the outermost shells, that is 2 electrons, though they will become 2 positive. So same thing goes to group 3, that is 3 positive. Okay, and then on the other way round, okay, when you go about non-metals, say for example group 7, you have like 27, 287, 2887, okay. So this one 28187, sorry for this one, okay. So for this, okay, you can see with 7 outermost shells, normally they need to gain 1 electron. So gain 1 electrons, they become 1 negative, okay. Group 6, that would be 26, 286. So you can see that in this case, we need to gain 2 electrons. So we become 2 negative, 3 negative. So basically, okay, when you look at that group number, you can tell the charges of them. Okay, by doing so, we can help a lot already. So some of you may ask, how about 4? Okay, you got 2, 4 or 2, 8, 4. We gain 4 electrons or lose 4 electrons. Sorry, this one, we don't have simple ion. We don't either gain 4 electrons, because too many extra electrons, they repel each other. It's not stable. Adding 4 extra electrons, they will be repelling each other. Removing 4 electrons in the center, the nucleus is not happy with that. Okay, it's difficult to remove all of them. Okay, so for group 4 elements, they don't have ions. So how can they do formations of bonding then? Okay, they will be using other kind of bonding, say for example covalent bonds in that case. So by simply using these useful tables, positive 1, 2 positive, 3 positive, 3 negative, 2 negative, 1 negative, you can see that actually in the table we can eliminate all these. Okay, they are not big problems anymore, because we know that sodium ion, they're coming from group 1, they must be 1 positive. We know that aluminium, they're coming from group 3, they must be 3 positive. Oxides coming from group 6, they must be 2 negative. So in the table you can eliminate all these. Okay, you can see that less things to memorize. Rule 3, okay, simple ion of transition metals actually. Okay, for transition metals, okay, first of all, for all the metal ions, they must be cation. You can't see simple metal ion, they are on the right hand side, okay, on the anion part. Okay, so all the metal ions, they must be cation. So when you make a wild gas, positive, 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 positive. Okay, so the transition metals, they got some special things as well. They got bracket behind it. Okay, so you have like iron 2 ion, you got iron 3 ion, you got copper 1 ion. Okay, so what this one is helping is the bracket, this Roman number, it tells you the charge. So if you are talking about iron 2 ion, iron is like this, it will be 2 plus. Iron 3 ion must be 3 plus. Copper 1 ion must be 1 plus. So by doing so, you see all the highlighted part. Okay, so this bracket, if I give you this one, actually you have no problems in talking about the ions, the charge of the ions. If I give you this one, you have no problems to tell me the name of it. Okay, only if you know the formula represent this copper. Okay, so you have 1 positive, you just bracket 1. Okay, so by knowing these rules, okay, many of the transition metals you can rule out. But of course, we do have special cases. Special cases, please pay attention to these two. Zinc ion and silver ion. You can see that even it is 1 positive or 2 positive, you can't see bracket right there. Because actually the bracket, why we have bracket and Roman number? Because normally for these elements, they have more than 1. You can see in this case, iron, okay, with 2 kinds of iron. So therefore we use 2 and 3 to identify with. Copper, you have not only copper 1 ion, we also have copper 2 ion here. So therefore, I will use a bracket to represent. But for silver ion, it is not. Silver ion will just have 1 only. So silver, you can't see bracket there. Zinc is also the same. Zinc only have 2 plus. So it is not necessary to add bracket 2 or bracket 1 right there. If you add, you will get wrong. Okay, so these two are very important example. You have to bear in mind. Okay, rule number 4. Simple anion, just like we talked about, cation must be positive. Anion, most of the time they should be negative. Not only this, okay, the name will change to IDE, end with IDE. What means by that? Oxygen, we call that oxide. Nitrogen, we call that nitride. Okay, bromine, we call that bromide. Okay, so all of them, they will end with IDE. When you see IDE, we talk about the simple ion. That means only one of them. Okay, only one atom in it. So basically, you have hydride, chloride, bromide, iodide, oxide, sulfide, nitride, and phosphide. All these are simple ion. And the chart of it, again, okay, remember, you can look at these. They are coming from group 7, group 6, and group 5. Of course, we also have hydrogen, which only have one outermost shell electrons. When you have gained one extra one, okay, they will become 2. Okay, so H minus, you have 2 outermost shell electrons. Still, this one is important as well. But there is one exception, which is IDE, but that is not simple ion. That is hydroxide. Okay. So rule 5, okay, polyatomic ion. Just like we mentioned, polyatomic ion, most of them, they are negative. Okay, we do have exception. Remember what is that? The exception is ammonium ion. So when we talk about the polyatomic ion, most of the time the polyatomic ion, okay, they got a center atom and then they will combine with oxygen. Once they combine with oxygen, normally they will have the name ATE and ITE right there, okay, 8 and 8. So ATE we're referring to more oxygen, okay, more oxygen. So this table seems that is a bit wrong, okay, so I should write N and S right there, okay. So when we combine with oxygen, you may combine more oxygen or you combine less oxygen. For example, for nitrogen, you can combine 3 oxygen or you can combine 2 oxygen. When you combine 3 oxygen, okay, this one we call that nitrate. More oxygen, we end with ATE. Less oxygen, we end with ITE. No oxygen, we end with IDE. Okay, so when you read this, okay, pay attention to the ending, okay, of the ions. For sulfate, okay, you have more oxygen. This time, okay, because sulfur and nitrogen are 2 different atoms. So sulfur, when it combines 4 oxygen, we consider that as more oxygen. When you just have 3, sorry, that is not a lot of oxygen. So for this one, we call that sulfate because you have more oxygen. And for this one, we call that sulfite, ITE. And if you have no oxygen, we call that sulfide, IDE. Okay, so basically we like that. Okay, and one more thing is a happy news. Okay, we are not necessary to memorize all these things or in the tables. Okay, we need to cross out 7 of them. Okay, but before that, okay, we just go through. We just cross out first. Okay, so we are going to cross out this one: cyanide ion, permanganate ion, chlorate, hypochlorite, and then we have silicate, chromate, and dichromate. So we are crossing these 7 polyatomic ion. You don't need for the exams, okay? So again, you can see that these are the group 7. These are hydrogen, remember. This is group 6. And then you have group 5. And then now you learn 8 and 8. Okay, 8. Okay, so most of them actually is covered already. Okay, if you pay attention to these rules. Finally, I will talk about the one without highlight, last rule. So last rules, okay, combination of ions, okay. So when you combine the ion, okay, you add the ions together, you simply add up the charge. What means by that? For example, hydroxide ion. So obviously you see hydrogen and oxygen here, okay. So you have hydrogen ion and oxide ion. When they add up together, remember hydroxide ion, O must be come up first. So it should be OH. So when you combine 1 positive, 2 negative, add together, become 1 negative. So this is combination of ion. Hydrogen carbonate, you're combining hydrogen ion and carbonate ion. Carbonate ion is CO3 2 minus. When you combine them together, you will have HCO3 negative. Okay, because 1 positive, 2 negative. Add up together, we become 1 negative. And then hydrogen sulfate, you have hydrogen ion and sulfate 2 minus right there. So when you combine, you have HSO4 1 negative. By doing so, okay, you can solve this one. Combination of ions. Combination of ions. Okay, so by basically doing this, okay, we can also easier to memorize 3 other ions. So these are the things that are listed in your textbook. Actually, I've already covered that. Okay, you can have a look at that in your textbook on your own. So class practice. So part A, state which of the following formulas stand for simple ion, polyatomic ion. Simple ion, I just use orange to highlight. Simple ion means one atom, only one atom, one atom, one atom, one atom. Where polyatomic ion will be more than one atom. That means 2 capital letter. Okay, and then what are the name of these ions? So this one, hydrogen ion, ammonium ion, hydroxide ion. These 2 are very, very important ion. Must remember that. This is manganese 2 ion, oxide ion, copper 2 ion, and permanganate ion. This one I didn't teach you yet. Okay, write the charges for the ion formed from the elements in the group of periodic table. Group 1, 1 positive. Group 2, 2 positive. Group 3, 3 positive. Okay, and then 5, 6, 7, okay, will be like this way. So you may ask, why the charge of ions, they don't write 2 positive in front of it? Actually, you write that way will be all right. You say 2 positive, 3 positive, okay? But in general, when you talk about charges, okay, you talk about the charges, not the symbol at the corner of the formula. In this case, okay, we put the charge in front, okay? It may be a little bit chaotic, okay, for you, but anyway, you write number first, charge at the back, actually it will be correct, okay? Atomic number of strontium and acetylene. With atomic number, that means the proton number of proton. So you have 38 and 85 respectively. So the charges of strontium ion is coming from group 2. Acetylene is also coming from group 7. So for strontium, the symbol should be Sr. Because it comes from group 2, so you know that the charges of the strontium should be positive 2. And for the acetylene, At, okay, that should be group 7, so that the charges should be negative 1. Okay, so when we write the formula, this is the charge, so you write this is the charge. When you talk about the formula, then you say Sr 2 positive, and then you have At 1 negative. Remember, when you write the charges in the ions, number come first. Okay, so that's it. So I know that there is a long way, okay, for you to memorize all these, okay, but try your best, okay. So the first one, main group, okay, the group number can tell you the idea of the charges. So these are the group 1, okay, group 1. So these are the group 2, okay. Barium is also group 2 elements, okay. So these are group 3, okay. And then you have like group 7 here. You have group 2 here, group 6 I mean, and then you have group 5 here, okay. These are group 5, okay, group 5, okay. And then that is fruit number 1, okay. Simple ion, okay, must be cation. So you see that metal ion on the left hand side, anion, okay, simple non-metal ion, sorry, should be non-metal ion. Simple non-metal ion, they will end with ITE and must be negative. They will be on the right hand side. Okay, and then for the transition metals, okay, they got brackets. The brackets tell you the charge. Okay, so the brackets, these are the transition metals. Transition metals, all these things, transition metals, and then you have transition metals. And you have transition metals, okay. So among these, okay, just pay attention to 2 of them. One is zinc ion, one is silver ion. They don't have brackets to show you. And then on the right hand side, we talk about polyatomic ion. Most of them, they are negative. We do have exception. We have hydrogen ion. Sorry, you have ammonium ion, that is positive polyatomic ion, okay. And then if you have oxygen with it, normally they will end with ATE and OTE. ATE means more O, ITE means less O. So the most important one will be sulfate, nitrate, nitrite. Okay, this is very, very important. Okay, and then last one, we talk about the combination of ions. Okay, when we talk about the combination of ions, okay, we learned about these two, which is H plus CO3 2 minus. We have H plus SO4 2 minus. We also have hydroxide ion, which is H plus and O2 minus. So basically, by these rules, actually you cover most of them already. Okay, so hopefully these videos can help you to memorize these tables of ions. In the exam, you must see them. Okay, oh, bye bye.